guys, welcome back to my channel. This will be another technical vlog that I'll be doing. I've been saying for a while I'm going to be fitting a lithium battery, and finally I've got the Roamer battery. It's the 200 amp hour lithium battery they do. It was designed originally for going underneath the cabin seats in the VWs, I believe, or T4, or some of the VW vans. But it should fit under ours, which measured it up, and it seems to fit under measurements. I haven't tried it in there yet. So we're going to give it a go today at fitting it out. It comes with an app as well. It's a Bluetooth app which is running at the moment. I don't know how much you can see on that, but it's telling me the voltage of the battery and how many amp hours the battery's got left, and there's a few other bits, temperatures and stuff. I've not played with it yet, so it's just been set up, just downloaded into it. If you want to know about the measurements for the width of this way from terminal side is 290 centimetres, and this way is 335, so it should hopefully fit in there quite tight. The only thing I have noticed so far is there's no way of fixing this down onto the floor of the van, so I'm going to have to work out a way of strapping this into position so it doesn't move in case of an accident. And that's basically it really. Two terminals, positive and negative. These are bolt-on terminals with nut and bolts, so they're much better than the clamp-on ones. And there's not much else I can say about it. I might as well go out in the van, show you what I've done in the van, because I've done a lot of work on the van, taking out some of the old electrics and that, and getting it ready for this to go in. So I'll grab the camera and we're going to have a look inside the van. So one of the first things I did was remove both seats. I took both out, although the battery is going to go over there on the left hand side. The right hand side, which has got the EBL, you can see the blue box for the EBL. I want to see whether the wiring, I can upgrade the wiring across to stop any. We've had some issues with voltage drops I've been told about, with lights flashing due to heating starting up. So I thought it's worth while I'm at it doing these jobs, I'll have a look at that as well and see if I can do anything about that. And there's a couple of other issues on my solar side that I need to sort out, so I've took both seats out for that reason. Well, one of the other things I just wanted to show you, I get told a lot of comments on some of the forums I'm on that any of this work that I'm doing should be done by a dealer. Now, I am an electrician and electrical engineer in trade, so I've got no problems with working on this stuff. But I just wanted to show you this sort of scenario. This is a dealer's workshop, so this is what a dealer has done. And this is your 240 volts connection block that the wires come into and then go into your EBL. So I'll just take the cover off to show you. Now, it's only a spade connection, which isn't an issue really, although there's no protective or mechanical protection on this from these cables pulling out. And as you can see here on the side, these are already dangling out like this with no protection around these wires. And if you was moving around here or pulling wires through and snagged on these, you could probably accidentally pull one of these out, and then you've got a live conductor, 240 volts, which could then touch your metalwork and liven up the van. It will chip out your RCD and fuses, but it's still, to me, when people say, oh, you should get your dealers to do this, well, these should be proper mechanical glands that hold these cables in, so they're physical, hold them in, not just big holes like this, which you can actually get little fingers in. So that is not exactly what I would call good practice for 240 volt electrical connections. But why I'm here, and the reason why I went down here to do this, as I said, this is the electrical connection, 240 volt, coming in here to power up your EBL, and there's the plug into your EBL. So when we're fitting lithium batteries, because a lot of people say not to use the EBL, and there's a good discussion to have about that, and I've spoke to some dealers about that, to disconnect this from charging your lithium battery, all you need to do is pull this plug out. And if you want to be totally safe, you could then disconnect that from this block to make this completely dead, and you could chase it back to the RCD. If there is MCB, if there is a Pacific MCB, you could disconnect that as well. Or the alternative thing that I'm going to be looking at is setting this on a gel charging mode, which you can't use all the time on lithium permanently. And the reason for that, I'll explain it a bit later if I can, is that the absorption charging on gel mode is a lot longer than lithium needs, and it also does float charging, which lithium don't like. And both 2 or 3 manufacturers I've been in touch with all said that if you put it on gel and it damages the battery, they will see it on the BMS on the lithium battery, and they won't cover any warranty. It'd be void in the warranty. Right, so the first thing I've done is disconnect the old NDS battery, which I'll be taking out to do any of the work around here just for safety. And I've also disconnected the positive, this is my positive feed to my battery to battery converter. That's the Victron DC-DC converter, which is also another name for them. So that's the positive, so that it's all electrically disconnected. And I've done voltage checks on the leads and they're all dead. While I've got the vehicle apart, I thought I'd do a quick walkthrough of the charging circuit on the van, and some of the things I've disconnected because I've fitted my own B2B. So first, this is the driver's side, and this is the pillar cover. There's a cover that goes over this with the little step light down the bottom corner there, which I've taken off. And these wires here, these big heavy duty wires, are the 12 volt supply from your engine compartment, permanent feed, which supply the charging voltage, and also the fridge power supply. So these cables here go down this loom here to this fuse block. Now this fuse block is normally bolted on the side here. There's a little bolt down the side, which I'll put back later. And so on this fuse block you'll see there's two white cables which has got a 15 amp fuse in it, and this is the supply from that 12 volt supply that I just showed you. This supply goes straight into your EBL, and this supplies the fridge, so that when your engine's running, it doesn't run off your ledger battery, it switches over to run off your engine. And that's what this fuse is for. So if you ever have a problem with that, which you probably wouldn't know actually, this is the supply. I'm not sure whether this also supplies the step. I could try it later on, pull the fuse out and see what it does. Then the one next to it, which has got a fuse missing because I've took it out, these are the yellow cables. These will supply the charging circuit for your ledger battery from your engine via that big supply I showed earlier. So these cables, it's only a supply going in, which is a 6mm cable, which is fine for doing lead acid or AGM batteries, but I've run 16mm through my B2B because I'm with lithium. So that's one supply of 6mm cable coming in, and then the yellow cable, which I've labelled up, coming out, goes into the wiring loom down here, and then runs all the way underneath your seats to your leisure battery side, and it connects into this chocolate block. If you're ever wondering what this block is for, which I still don't understand why they did it, this is where that fuse cable comes into. This is this one here, which I've labelled up number 1. It just connects into here, joins onto another cable which has got no colour coding on it at all. That then runs back under the floor, comes through into this loom here, feeds back into this loom, comes up to here and feeds into the main chocolate block up here. I've took mine apart, but remember there's a 4-way block up here, so that's feeding into there, and that's this cable here. So it's one 6mm cable coming in. From there, it then goes into these cables, this is the other side of it, and then into your EBL. And I'll show you on the EBL where it connects. So this then feeds into the EBL. You can see just behind this black cable, there you go, I've got 2 pins missing. There's 6 pins there, connections, and 2 in the middle are the charging circuit from your starter battery into your EBL, which then feeds to charge your leisure battery. So that's them 2 wires that came out of this chocolate block, which I've disconnected because I'm taking mine out because I'm running mine separate. There's an additional green cable which went into this block, so that would have connected, if this block was here, these 2 cables would have connected into here. So this additional green cable, which also goes down through the loom down here, over to your battery compartment and connects into this block, which has got nothing on the other side of it. This block doesn't actually do anything, it just joins the 2 cables here, and it runs another green cable over. So I'm going to be having a bit of a tidy up with this, because just in case someone hasn't seen my other videos, my charging circuit, as you've seen earlier, my B2B, I have permanently run 16mm cables from here. They go straight away across and under here and straight into my leisure my starter battery. So I don't need all that charging circuit you just saw on the van, because mine are directly connected via 16mm via this B2B. I'll just show you a couple of things I've done. So over here, you remember I had a connection block for the earths. I've disconnected that and made this one up, which is a bit more neater. And they're all bolted in position, so they can't pull out easy, and that cover will go over at some point. I've also removed the positive one. I've got this positive one going straight through to the battery, and the original one. So I've run 2 6mm cables now from the battery side into here. Both that one there and that one there. So there's two going into the EBL now, straight over to the battery, so it just bulks up to reduce the amount of voltage drop. Over this side as well, I've done is the heater circuit, which I think I showed you. These two cables now go straight over to the battery, which is made a little bit reduced on the flickering of the lights when the heater's on. And other than that, I've removed, tidied it up, and I've removed all the cables, original cables that are there. If you remember, there was a connection block over here which I've removed. I believe, looking it up now, that connection block was for people that have the Adria. When the Adria fit the B2Bs, they use that connection block to run the cables back and forwards, and because I've got my own which is running direct straight through to the battery at the front, I've decided to take all that out to reduce the amount of cables. So I've still got my power supply, like I say, coming in here from the starter motor, starter battery. That then feeds down into this isolator. It's not used for a fuse, because I've got a fuse on both batteries. This is purely so that I can isolate this device if I need to, like it is now, if I'm working on it. This fuse here, the yellow cable, that was the original one. It goes from the positive of the battery into the EBL, and it tells the EBL to switch on. So if the isolator goes or fuse goes, this will disconnect this power from here, be disconnected, and the EBL then switches off. I've got a positive bar in here now to connect up all my positives. So solar comes into here, the two positives going to the EBL come into here, the B2B is coming into here as well. This obviously connection is going into here, and then you've got a connection going out to the battery. I think that's about it. Everything the other side is all insulated, and I need to make a cover over here and a cover down the side here so that nothing shorts out. Right, on this side of the battery compartment, I've moved my negative bar over to the side here to give more space for the battery. So it's all the negatives going onto this buzz bar, and down the bottom, right down the bottom, is the shunt, which is used to give me a display indication of the battery amount of power I've got left. And then originally there was an isolator for the battery on the side, on the outside panel, which was okay, but it couldn't take the 16mm cables easily. So I've removed that and put this isolator in, which is a much more bigger isolator for the size of cables that I'm using. I can still get to this from moving the front flap down in emergencies, and then that gets into a 40 amp mega fuse, and then from there it goes to the battery, and negative here will go to the battery. So hopefully most of that makes sense. It's quite simple. You don't have to do all this. You can actually fit this battery in play, connect it up to the original wiring, and just put a B2B in the connection blocks which used to be down here, and then that's about it really, and just set up your solar and everything to lithium. So for now I'm going to get the battery in place and then sort out some way of strapping it down. Right, so as you can see, battery's in place. It fits quite low on the seat line, so the seat should easily fit over the top of this part of the battery, so that fits in there nice, and it does fit in there nice and snug in this department. It's a bit tighter for my setup than I calculated, but that's mainly because I fitted this piece of wood which allows me to bolt on the B2B, and it allows me to connect it on the buzz bar to it. So that made it a bit tighter, so it's snug to that, which means I've had to pull the cables up and run them across the top. But it's in there now. The other thing I would change if I was going to do this again, or two things. One, I'll probably put a wooden plate on here to move my terminal bars over there, maybe. Still would be a bit tight. But the other thing is I would have done the battery the other way around, so that the terminal bars would be on that side, and then they'll be accessible then from the flap at the front of the seat. But then again, it's not often you're going to need to get to these terminals. If I was had to get to terminals, take them off for some reason, to take the battery out or anything, the seat's got to come off anyway. So all connected up and powering at the moment, the van. I've not set up any lithium settings on the solar yet. I haven't connected the solar up, that's still disconnected, and I've just run through a quick test. So looking at the app, if you can, comes out on the screen over here, you can see we've got 0 current coming out. We've got 199.06 amp hours left, and we're running at 13 volts. Average volt is 3.25. I expect that's per cell, so I'm not too worried about that. And the time left 43 hours I expect, but then I suppose that depends on how much you're putting on. I think the top of the app, this bit here, is an accelerometer thing for when you're driving. I don't know what this is for. I'll have to look it up, but I'll just get some things up and running on the van. Right, so I've just turned the van power supply on. This is my amp or meter system that I use. I've got to set it up for the lithium. It has to be updated for the percentage, but it's giving me the current output. I've got some lights on at the moment, pulling 1.8 amps out of the meter from here, and if you look at the app, it's pulling 1.9 on the app, on that green circle on the right hand side there. So it's pretty, this is pretty accurate, and to this as well. What I'll do is I'll turn a load more devices on, get it up to quite a lot of higher current. Right, so I've now got the fridge running, the TV's on, and a lot of my lights are on. And I'm putting 8.3 amps out of it, according to my shunt meter. And again, if you look at the app, it's putting 8.3, 8.2 on the app. So yeah, I'm quite impressed with that. It's very accurate. That's quite good. It's also dropping the hours down. The time is 26.5. Whether that's in focus, I'll just bring this down in. So I'm hoping this comes out in focus. So we're putting 25 hours left on the battery at the rate we run that. We're putting 120 watts out of the battery. So we've got a couple of days, quite a few days without doing any charging, and I'm running everything at the moment. The only thing that's not running is the heater, and if the heater was on, that would bring this up probably about another 5 to 8 amps. Right, so I've just been running this now for about 15 minutes, putting in around 7 amps. As I said before, the app is being quite accurate. What I'm going to do now is switch everything off, because it's saying on here that I've got 192 amp hours remaining, so I've used a bit of the amp hours up, and I want to now turn the solar on and see how well this charges. Right, so I've just switched everything off and put it onto solar. It's quite a bright day out there today. I'm getting 2.5 amps going into the lithium, which is pretty good for today. That's going to charge quite fast. Just to show you the app for, try and get it in a bit of darkness, this is the app for the Victron. So to change this setting, I went into settings, top corner, go into batteries, go into this one here, which would usually be factory. It'd either by being factory or user defined or something. Go to select preset, and then you can scroll down till you see lithium. So that's what I've set this to at the moment. 14.2 volts on absorption, float's 13.5, which means it shouldn't charge on float. And I'll look into this a bit more at a later date. And looking at the other app for the battery, I've got 2.9 to nearly 3 amps going into the battery now. You can see there's no negative sign. Before it's a negative sign, which means power coming out, and now it's going in, charging up. So pretty impressed with the speed that this is charging. It even gives you a charge time down here of 2:30, 2:41 and 2:30. It's going down. Right, so the final setup on the battery side, I've now bolted on a metal strap along the top to hold it down for accident purposes, and I've also put a plastic cleat angle bracket down now to stop it moving side to side, but it is quite tight in here, so I shouldn't think it will cause any problems. Now when the seat goes on, there's a bolt that goes through this hole here, and this recess where it drops down is lower than what the seat is. The seat actually goes dead straight like this across, so you can see how much space you've got there to be able to put a bolt in like that and to strap this down if you decide to strap it down in this way. So this side of the van is now finished and ready for the seat to go back in. On the opposite side, for the 240 volt, remember I had that rubbish connection box that they put on here. I'll put a better one in with proper cable glands. I probably won't be using this power supply, so I'm leaving it disconnected at the moment because it's not set up for lithium charging these EBLs, even though people keep saying you can do it on gel. The absorption time on these for gel is a lot higher than what lithium are like, and the float is a lot higher than lithium like. So what I might do in future, if I ever need a power supply charging, like electric hookup charging, I'll probably put one in here, down this area, and then connect it into this box, and then wire it straight into these two wires, which is 2 wires that go to the battery anyway. I don't think I'll be needing it. A 200 amp hour battery should last me quite well. And just down the front here as well, just show you, hopefully this comes out in focus. One of the fuses I've disconnected is 20 amp. It says charge int next to it, which is your charging circuit when you're on mains. So when you've got the mains hooked up, it charges out onto here, and it charges through this 20 amp. Although we moved the power supply, the 240 volt power supply, if you leave that fuse in, I found I'm getting 120 ohms across the positive to negative. So I'm getting a current draw because it's going into the transformer internally of this, which is a low resistance, but will have a back EMF, I know, but it will still cause some sort of current draw on your positive and negatives, and it's not needed. So because I'm not using it, I might as well take the fuse out. So that's the fuse I took out, and then that brought the resistance of the circuit up quite high. Right, so that's everything now. On the right hand side over this side, as you can see, I've got the MPPT Victron Solar with its own isolator and fuse going straight across to my battery, and over this side I've got my B2B connected straight to the starter motor into the battery. Everything's connected up now and ready for the seats to go back in. I'm just going to wait for the batteries to charge up to see how long that takes, and then we'll get the seats back in and all the covering around the sides back in. Right, so while I was sitting here waiting around, I thought I'd switch the engine on to see how the BB works, because we've got some charging on the battery to be done. And you can see with the battery engine running, we're picking up to between 30 and 33 amps. 30 of it will be from the B2B and the rest of it will be solar. It does show you why you need a B2B with lithium, because that's quite a lot of amps just on that lot, and the B2B is a 30 amp B2B, so it's reducing the current flow. Without that B2B, I expect to be pulling a lot more current off the engine. It's brought the time also down to 10 minutes, so within 10 minutes I'll have a 100% fully charged battery, but I'm not going to leave my engine running for the next 10 minutes. What I'll do now is just show you the B2B, although there's not much to see on the app. And there you go, there's the B2B. I did exactly the same on this as I did with the solar. Top right hand corner, you connect to that little spanner, cog even. Go into the settings and reset this to lithium. So this is now running on lithium, and there you can see it's bulk charging at 13.8. Now I reckon I could up that to 14.2 if I wanted to change my settings, but if I get a full charge in 10 minutes I probably won't bother. And then on the solar, see if we're pulling anything still. Yep, we're getting a little bit on the solar, so we're charging the batteries at 2.2 amps bulk, so that's why I'm getting the 32.2 in total. So I'll go back to the actual other app, and that's it. So you're getting about 30 odd amps charge. So it's pretty good really. I've got 9 minutes and it'll be fully charged, but like I say, I'm not going to leave the engine running for that time, so I'll just turn it off. Right, so that's it. The seats are now back in place and all the covers are on. So that's the battery's finished with being fitted. There's a slight modification I'm going to do with these bottom back covers, which is cutting the bottom strip off, plastic strip off, so they sit back flat, because they're not sitting quite flat, they're catching on the cables and they're running underneath the floor. But other than that, I'm pretty happy with that. It's quite a nice little fit. It's easy to get to the fuse at the front, which I'll show you in a second, and that's pretty much it. It's now about 20 to 6 at night, still quite sunny out, and you can see I'm still charging at about 1 amp. So the battery's not 100% yet, so I can't set up that gauge. As you can see on here, I'm showing 1.2, 1.1 amps going in, and the batteries are sitting at 199.01 amp hours. It'll probably take a while to get up to 100%, and as soon as I get up to 100%, I can set up that gauge I was just showing you. Looking at the Victron. So as you can see there, I've got 1 amp going into the batteries, so it's still bulk charging. Because I've switched everything off and back on again, it goes into bulk charging for a little while, and then it'll drop down hopefully, and get it up to 100%. So far, pretty good. So like I was saying as well, under the driver's seat, if I just pull this out, you can see there's quite a bit of space here still to get an electrical charger. I reckon you can get one of the small lithium Victron chargers for the battery, which will connect into these red cables, and the 240 volts is already in this compartment, so if I ever need one, that's where that will go, but I'm not sure whether I'm going to need it yet. And over the non-driver's side, if I open that up, you can see I've got easy access there to the fuse, and put my hands back there I can get to the isolator to isolate this if I ever need to. Right, so that's it for this vlog. Hope you enjoyed it. Please give us a thumbs up and subscribe, This will probably be the last one I do on power supplies on the van, because it's pretty much all done now. I can't see any other things I need to do of any improvements, unless I end up putting a lithium mains charger in. If I do, I'll do a vlog of that, show you how to install it, but it's pretty straightforward really. Other than that, what we do, we're going away in a couple of weeks, so I'll let you know how we get on, see how much power we pull out of this battery and see how fast it charges on solar and the B2B. So that'll be it for now. Next weekend we'll be away, so I'll do a little vlog then.